You know that feeling, right? A particular scent, maybe, or just a few notes of an old song, and suddenly it transports you.
Oh, absolutely.
Not just to a memory, but like the whole scene floods back.
Yeah, the emotions, the sounds,
Right.
everything.
Exactly. Even the temperature sometimes. It's such a powerful reminder that our memories aren't just, isolated files stored away somewhere.
Mm-hmm.
They're deeply woven into the context, the whole environment where they happen.
That's a perfect way to put it.
So today we're diving deep into something called contextual resonance. It's a breakthrough concept from a field called Sophimatics.
Right.
And this isn't just some academic buzzword. It's really about pioneering AI that truly understands. AI that encodes the entire environment around a memory, not just the raw data.
Imagine that.
Hmm.
AI with something closer to intuition, not just recall.
Yeah. So we'll be exploring how context and this idea of nonlinear memory, these innovative hybrid AI models, and even how time itself in subtle ways plays a huge role in how we and maybe future AI actually learn and remember things.
And our mission here for this deep dive is really to explore how AI systems can, move beyond that simple recall.
Just spitting back facts.
Exactly. To genuinely comprehend and react. The goal is designing them to encode the full environment where memories are made.
Okay.
And what's really fascinating, I think, is that this isn't just about building smarter AI. It's also about uncovering the basic mechanics of remembering.
For ourselves, too.
Yeah, exactly. How much we can learn about our own minds by looking at these advanced designs. It's quite insightful.
Okay, so let's really unpack contextual resonance. What does that actually mean day to day? How is my mind, interdependent with my environment when I'm trying to remember something?
Well, it's a core idea.
Yeah.
The human mind doesn't store information in a vacuum. It's just not how it works.
Right.
When you form a memory, you're not just recording the fact, say, someone's name. You're also grabbing bits of the environment, your emotional state then, the sounds, the smells. All of it gets bundled together. So later, when you try to retrieve that memory, those same contextual cues, they act like a really powerful key, unlocking the whole thing.
That makes so much sense. And there's that classic study, isn't there? The one that really nails this. I'm thinking Godin and Baddeley, 1975, with the Esquiubi divers.
Exactly. That's a fantastic example, yes. They had divers learn word lists, either underwater or, just on dry land.
Right.
And the really remarkable finding was how much better they remembered those words when they were asked to recall them in the same environment where they learned them.
So learn underwater, recall best underwater.
Precisely. Learn on land, recall best on land. It's just such a vivid demonstration that context isn't just background noise. It literally becomes, part of the memory itself.
Wow. Okay, so if our brains are wired like that, how does Sophimatics take this idea, context isn't just noise, and translate it to AI? What's it mean for an AI to remember where and when it learns something?
Well, for AI, this is a pretty big shift in thinking, a paradigm shift, really.
Right.
Instead of just recalling the content, like a specific data point or an answer, Sophimatics aims for AI to recall it in the right context.
Ah, I see.
So this means actively embedding things like environmental cues, time markers, maybe even simulated sensory data directly into the AI's memory structures.
Which is different from how it's usually done.
Yeah, many, let's say, traditional AI models, they treat memories more like isolated facts. They're kind of divorced from the conditions under which they were learned. But what we're pushing for here is AI that doesn't just know what it knows, but also where it learned it, when it learned it, and crucially, why that specific context matters for what it's doing right now.
It sounds like building a much more nuanced, almost human-like understanding.
That's the goal, yeah.
That's really insightful. So it's not just about pulling up a fixed file, is it? This contextual resonance idea seems to suggest our memories are constantly updating. Is that where it gets really interesting for you?
Oh, absolutely. That's key. Our memories aren't static files on a hard drive. They're incredibly nonlinear, meaning they let us adapt our understanding, our beliefs, as new information comes in, or as the situation around us changes. Imagine if memories never changed, how useless that would be in a world that's always shifting.
Right, you'd be stuck. And we see this even in just how our attention works, don't we? Like Treisman's dichotic listening experiment from '64, wasn't it? Can you refresh us on how that showed this nonlinear updating?
Yes, it's a fantastic illustration of just how powerful context is, even for our immediate attention. So participants wore headphones, right? Listening to one stream of info in one ear, maybe a story, and they were told, ignore the other ear.
Okay.
But If something really relevant, like their own name, was suddenly slipped into that ignored ear,
Their attention would just snap to it.
often, yeah,
Mm.
instantly, their brain rapidly processed that new context, their name, as critically important. It overrode the previous instruction to ignore. So
Wow.
it wasn't about simply recalling a fact. It was the brain actively recalibrating its focus based on this new, super salient contextual input.
So if our brains are that good at recalibrating on the fly, what does that mean for AI systems, especially those maybe designed without this deep grasp of context?
Well, it points to a really significant challenge for AI development.
Yeah, okay.
If a system is only trained to pay attention based on the data coming in right now, it's going to struggle massively, especially when the context around it shifts unexpectedly.
Right, it gets lost.
Exactly. Sophimatics tackles this head-on by making memory a central, active component. It's not just about pulling info out, it's about the recalibration, the updating of what's already stored and attended to using new data.
So it can adapt.
Precisely. This lets the AI dynamically shift its focus, more like we do when our environment changes, instead of being stuck on one track. It helps ensure the AI doesn't just, process information, but actively learns and evolves its understanding based on a richer, more contextual awareness.
Okay, that's a lot to wrap your head around. If our memories are constantly updating with context, and maybe time isn't strictly linear, how do you even start building an AI that can handle that complexity? Is there a specific approach for Sophimatics favors?
Yeah, that's where these hybrid models come into play.
Mm.
And they offer a really robust solution, actually.
Hybrid models. Okay.
We're basically looking to combine the strengths of different kinds of AI architecture to get the best of both worlds, so to speak.
Can you break that down? What are these best of both worlds? What exactly are we combining?
Okay, think of it like this. On one hand, you've got symbolic interpretation layers.
Symbolic, meaning like logic, rules.
Exactly. They're great at understanding structured input language, rules, facts like you'd find in a knowledge base. They give you precision, interpretability. You can see why it reached a conclusion.
Okay, makes sense. And the other side?
The other side is distributed neural representations. Think deep learning networks here.
Ah, the pattern matchers.
Right. They're incredible at learning subtle patterns, making broad generalizations from huge amounts of raw data images. Sounds often without needing clearly defined rules. But sometimes it's hard to know how they learned it.
So we're trying to marry that logical, rule-based side with the more intuitive, pattern-spotting side. What's the big win from doing that?
Well, a key insight, and this goes back to researchers like Vermter and Leonard in the late 80s,
Good.
is that by combining these, you get the really robust performance and the generalization ability of neural networks.
Right, handling new stuff.
But you also get the precision and the explainability of the symbolic rule-based systems.
Ah, so it performs well and you can understand why.
Exactly. And it helps avoid this problem called overspecificity. It's where an AI gets trained on very specific examples and then just falls apart if it sees something even slightly different.
Right.
It only recognizes exactly what it's seen before.
Right, it can't generalize.
Precisely. This hybrid approach lets the AI handle novel situations much more effectively by leveraging both its explicit knowledge and those learned patterns.
That makes perfect sense. It's like giving the AI both the rulebook and the street smarts. Okay, switching gears slightly. When we usually think about memory, our minds often jump straight to a timeline, right? A linear sequence.
Right.
Event A, then event B, then C.
That's the common picture.
But what if time itself is actually way more complex, like a non-linear element in how we remember and process things?
Indeed. We tend to visualize time as that straight line,
Yeah.
but our actual cognitive processes, they don't always stick to that neat sequence.
Right. I know cognitive theorists have proposed models like the AA architecture, which, simplifying a lot, suggests our brains aren't just processing one thing after another, but in these overlapping, maybe 200 millisecond cycles of memory, attention, learning. It's much messier.
That's a good way to think about it, yeah. Messier, more dynamic.
So what does this nonlinear view of time mean for Sophimatics and building these AI systems?
It means we absolutely cannot treat time as just a simple sequence for storing things.
Okay.
In Sophimatics, updating memory doesn't always have to happen step by step, A, then B, then C. It can be recursive,
Recursive.
meaning the system can actually loop back. It can revisit and reprocess previous information, maybe integrating new context that just came in, or even reinterpreting older memories based on new cues.
Whoa.
This temporal dimension with these nonlinear dynamics is absolutely crucial for AI models to really handle memory properly. If you connect this to the bigger picture, AI needs to see time not just as a timeline for storage, but as this complex web of relationships that deeply influences how memories get processed, stored, and pulled back out.
That adds a whole other layer of complexity. And you mentioned earlier that this understanding of nonlinear time and context even shows up in language itself. Can you give us an example of that?
Oh, absolutely.
Yeah.
Think about how we use time, tense, and aspect in everyday language.
Okay, like past, present, future. Sort of, but it's richer than that. When you say something, the real meaning, the relevance, isn't just about the verb's tense, was it past or future. It's also deeply tied to, when you actually said it, what linguists call the utterance time.
Ah, the moment of speaking.
Exactly. And all the other little temporal cues sprinkled through the sentence or the conversation. This is something linguists like Comrie, Reifenbach, Wendler really dug into.
So it's not just what happened, but also maybe when did you tell me it happened and what else, how confident you are about it? Is that part of it too?
Precisely. We often rely implicitly on what are called evidential systems. Basically, are built-in ways of signaling how sure we are about something.
Yeah.
Don't worry about the fancy terms like temporal deictic center or temporal evidential center. Just think of it this way. The deictic center is about when we're actually talking about the event. The evidential center is about our confidence level. How probable do we think this event is?
Yeah. So as someone like Stephen pointed out, these linguistic bits and pieces don't just place an event in the past or present. They situate it relative to both, what it was described and how believable we find it. AI needs to get these nuances to truly understand us.
Wow, that adds so much richness. It's like our language itself is designed to encode all this context and confidence. Okay, finally, let's talk about something really novel in Sophimatics, these contextual memory triggers.
Ah, yes. This is exciting stuff.
We know this feeling so well as humans, right? That specific scent, a few bars of music, even just the way the light hits something, and it instantly triggers this cascade of memory or switches our attention completely. And that whole mechanism feels so dependent on the context. It's that sudden aha moment. How on earth do we start applying that principle to AI?
Well, the core idea is to create what we're calling attentional nodes.
Attentional nodes, okay.
These nodes are designed specifically to capture not just the main stimulus, the thing you're focusing on, but also all that rich contextual information floating around it at the moment of learning.
So the sights, sounds, maybe even simulated feelings.
Potentially, yes. And the stimulus itself gets represented as a symbolic index, basically, a pointer that links directly to its meaning within the AI's memory.
Okay, so it's linking the what with the where and when and how.
Exactly. It's about building a system where a particular combination of these contextual cues can actually generate its own kind of aha moment for the AI, re-triggering a whole related memory complex.
So an AI could, say, perceive a specific pattern of light, temperature, and sound in its environment. And that specific combination instantly brings to mind a whole set of related information or maybe a past event it experienced, just like a smell does for us. Is that the idea?
That's precisely the kind of capability we're aiming for. The potential here is just immense.
Yeah.
This kind of combined architecture could allow an AI system to genuinely reprioritize its entire knowledge base, its hierarchy of information, based on the exact circumstances in which it first encountered or learned something.
That sounds like real situational awareness.
That's the ultimate goal. Nothing less than human-level situational awareness and recall. We're talking about AI that can dynamically reinterpret, recalibrate, intelligently rearrange all the information it's previously attended to by constantly considering its surrounding context and that complex temporal dimension.
So it's not just about AI processing data anymore.
No, not at all. It's about building AI that remembers, that understands with the richness, the depth, the adaptability of a human mind.
Okay, so wrapping this up, what does all this mean for you listening?
This deep dive into Sophimatics, it really shows us that memory, whether it's ours or artificial, is just so far from being a simple recording device.
Right, it's not passive storage at all.
It's this active, dynamic process, deeply tangled up with context. It's capable of adapting, updating, even being triggered by these really subtle environmental cues.
And it highlights that a true, nuanced understanding of any information requires you to understand the when, the where, and the how that information was acquired.
Yeah. It's about moving beyond just rote recall towards genuine comprehension, real adaptability, and intelligent reasoning within the world.
For us personally, I think it offers this fresh, kind of profound perspective on how our own memories work and maybe why those sensory triggers, that smell, that song snippet, are just so incredibly powerful.
Hmm.
And for AI, well, it charts a really clear and exciting path forward
Hmm.
towards systems that don't just crunch data, but that truly understand and reason inside these complex, always changing environments.
So our final provocative thought for you to mull over is this. If context is so fundamentally crucial to understanding and memory, how might we need to rethink the very way we present information,
Hmm.
both to each other as humans and to these future machines? How can we present it to maximize not just retention, but real insight, and maybe even trigger more of those powerful aha?
Hmm.